All right, well, we'll go ahead and get started then. I'm Mark Gelfo, TLC Engineering Solutions. And if you've seen any of my presentations in the past, I'm sorry, but this is, some of it's going to be familiar. I generally like to talk about emergency power systems and how we test those. And this time, I'm calling it a series now because we've done 2 or 3 of these with this kind of the same theme. We're going to talk about the fuel systems specifically. So also, if you don't know or like Star Wars and The Mandalorian, then you're just going to be a little bit lost on some of the, some of the graphics here. So that's so sad for you. Anyway, with great emergency power comes great responsibility. Don't forget the fuel system. So we're going to skip through those slides. The learning objectives, we're not going to go through those, but basically my hope is that at the end of the session that you'll have a greater appreciation and understanding for how important fuel systems are in the whole emergency power commissioning process. So again, if you've seen my presentations, you know I'm an electrical guy. Most of you are. So well, let me ask. Let's take a little poll. How many commissioning providers, commissioning authority, people who do commissioning do we have here? Raise your hands. Oh, okay, so a couple. Now keep your hands up. How many of you are electrical by your primary discipline? And keeping your hands up, how many of you have commissioned emergency power systems? See, hands go back up, and that's not what's supposed to happen. Y'all think you can do that, but that's not the case. You can put your hands down. Thanks. Okay, now I know my audience, but my background is obviously electrical. So the first question is, what the heck do you know about about fuel systems anyway? Well, as it turns out, over my career of testing emergency power systems, I've spent an inordinate amount of time dealing with the fuel systems. Even the generators and transfer switches and all that seems to go reasonably well, and then I end up spending the bulk of my time talking about and trying to get people to make the fuel systems work. So call it, on-the-job training or, school of hard knocks or whatever, but I've picked up a few things about fuel systems along the way. And I certainly don't claim to be an expert in plumbing systems or fuel, and there's a lot of people that know a lot more about it. But from a process and how important it is and what we do as part of the overall emergency power systems commissioning, that's what I'm going to talk about today. When I'm in commissioning meetings with contractors or, we call them red zone meetings, but meetings to get people prepared for, okay, here's how we're going to do the testing for the emergency power systems, I get asked the question, well, what do we need to do to get ready? What do we need to have done? Which is in itself a silly question, but I break it down into 3 big blocks for them. There's to be able to test the entire emergency power system, we need to have the EPS, the generator itself, generators, and switchgear. That has to be done and tested, including load bank tests. The transfer switches, they need to be done, tested, set up, programmed, all of that. And the fuel system needs to be done and tested and pumps and all of that. And I think people stop listening after I say transfer switches because they do the first 2 and then the fuel system is just not ready. So that's why these 3 blocks. And until those 3 are done, we cannot proceed on to testing the full system, the full emergency power system. And I'm backed up by that from NFPA 110. And NFPA 110, just to go over some common definitions, I already said EPS, that's a term that means emergency power supply, which is the generator and its switchboard and switchgear. But the EPSS, the emergency power supply system, is the overall emergency system, which includes, if you could possibly read that purple part there, it says fuel system. So that's part of the system that we have to test, backed up by code. And in case you're new to the planet and don't know how systems work, we put fuel in the main tanks. Usually there's a big primary tank above ground, underground. It feeds to a day tank, a smaller tank that is in closer proximity to the generator, and then it feeds the generator itself. Now there's lots of different systems, lots of different fuel types, but I'm going to generalize. Most of what I do is in some bigger systems where that's kind of the primary way the system is configured. And we're going to talk today about diesel fuel systems, even though there are certainly natural gas generators and LP systems that tend to be smaller generators and a little simpler. But I'm going to focus today on diesel systems that look similar to what I was just talking about there. So if you have questions about natural gas or LP, just keep them to yourselves and we'll talk about it later. No, this was not drawn by a 5-year-old. This is my highly technical diagram that I drew because I couldn't find a simplistic enough diagram that showed the major components that I wanted to talk about of the fuel system, just so that everybody's got a kind of a common base of where I'm coming from. Got a main tank that has fuel in it. There's supply pumps usually that then go and feed the day tank, and then from the day tank over to the generator, and then the return lines back to the day tank, and then usually return pumps. You can't see that laser, I don't know why I'm pointing. Return pumps that pump fuel back from the day tank back to the main tank. And there's a lot more detail to it, and there's float switches and solenoid valves, some of which I've tried to show there, and depending on the way the system is arranged and configured, it might look a little different. But that's the fundamental building blocks of the system that I'm going to talk about when I'm talking about supply pumps and return pumps. This is the diagram that I'm talking about. This is the way that we do it. So why am I talking about that? I kind of already hit upon this, that it always seems to be an issue on my projects. Maybe it's just me. But fuel systems are an important part of the emergency power systems. And I always say that my job as the commissioning provider one of my jobs is I'm looking for single points of failure in the design phase, in the construction phase, in the testing phase, beyond. Where are those single points of failure potentially living that are going to make the system not work? And if you go through a list of the top reasons why generator systems fail, emergency power systems fail, right after batteries, it usually has something to do with the fuel system. So this is not an unimportant thing, and I'm surprised at how often it gets overlooked, because if the fuel systems aren't working, your generator's not going to run for very long. Single points of failure. So like any good commissioning process, I structured our presentation to talk about the different phases. So talking about the design phase, assuming that we are fortunate enough to be involved in the project during the design phase, what do I look for during the design phase that's going to set us up for success in subsequent phases, by the time we get to acceptance testing? Do you guys all not appreciate these slides? This is as nerdy as it gets, man. All right. I do these presentations mostly for me. So some of the obvious, or what I think are obvious things, but I am surprised that aren't on the drawings a lot, are, what type of fuel is going to be on the is specified or going to be in the job. Do the details match the floor plans, match the schematic layouts? Do the drawings tell a story, right? Do they really show how the system is supposed to work? Are the sizes of the tanks indicated? Are there calculations? And I'll talk about calculations and why I think that's important for us to care about here in a little bit. Low-level alarms and sequences of operation. Those are the big things that I'm looking for that are I shouldn't say hardly ever, but they're often not there or not in as much detail as we would like to see. So that's pretty straightforward. But like I said, I've been harping lately, in the last couple of years, on design engineers and anybody that will listen to me, frankly, that the construction documents should tell a story, right? Most of you are commissioning providers in one way or another. You get a set of drawings and you've never seen it before, and so you've got to go through it and try to make sense of it. And of course we do, but designers forget that not everybody's been working on the job for 18 months, and the drawings should be very clear, concise, and tell the story of the project. And this is an example of a way I think it should be done. It's a fairly complicated system where two new generators were added to a lineup, connected to existing fuel systems. I know you can't really see those details, take my word for it. But two new generators and 2 new day tanks, connected to this existing system with 3 existing main fuel tanks, and it's one very clear diagram of how everything's interconnected, and I didn't show it here, but there's a sequence of operations and stuff. This is a good example, one of the best I have seen. And then I see lots of examples where this is not the way to do it, where there's obviously boilerplate details that have been just put on the drawings that don't necessarily match each other, let alone match the floor plans or match the piping or, you know, whatever. And it's really hard to try to tell, well, did they really mean what's in this? These valves are supposed to be here in this detail, but they're not in that detail. Is that an omission or, you know, so if anybody has any influence on design engineers, encourage them to, you know, not use boilerplate, make sure everything's project specific, and make sure the documents tell a story. This is another good example just with some more labeling, you know, sequences of operation, the different points and the different major components of the fuel system, some of which we're going to talk about, monitoring systems, and, you know, I already talked about main tanks, and we'll talk about fuel quality and polishing systems, day tanks, and, you know, just having a diagram in the first place sometimes is a big win, because I've commissioned jobs that don't mention much about the fuel at all. And having a sequence of operations, I'm going to say that a bunch of times, is very important. Other considerations, other things that I look for as I'm reviewing the system, you know, basically, you know, things like, are there different types of fuel, or the generators maybe dual fuel, or are they using biodiesel? Have they addressed the fuel quality issues? Because fuel, as you probably know, can't just sit in a tank forever and, you know, expect the generator to run. Has that been addressed? Are there fuel polishers or fuel cleaners of some sort in the distribution system? You know, those types of things. And if they're not, then, you know, that's where we can have influence during the design phase, obviously, and make those recommendations and talk with the team and the owner and all, you know, all that, and hopefully get to add things that maybe should have been there in the first place. So like most of you can probably write down some of your design review comments without even opening the drawings, just because you see them time and time again. It's a kind of an ongoing list of electrical commissioning items that I seem to see on every job, and usually I'm talking about, for emergency power systems, the biggest thing is the fact that there's either no or a lacking sequence of operations. In this case, we're going to talk specifically about, you know, sequences of operations related to the fuel system. So is there fuel information on the drawings, and is there a sequence that tells me exactly what is supposed to happen and when, as to what pumps come on and at what levels, and so I'm going to harp on that a lot. So some of the key components of that sequence of operation, things I'm going to look for, you know, that's a detail, just a generic detail showing, you know, how many float switches you could potentially have in a day tank. Sometimes we talk about just the high and the low, but you can have high, high, and low, low, and, you know, it's depending on what's been specified, you know, is any of that specified and called out? You know, are the float switch levels set for the main tank and the day tank? Are they called out to where they're supposed to be set? And then when the supply pumps are supposed to kick on, at what level do the supply pumps kick on? At what level, at what point do the return pumps kick on? What valves open or close is associated with that? It can be fairly complicated, or not. It can be fairly simple too, and that's fine. High level and low level alarms, when are they supposed to enunciate? I'm looking for all of those things in a sequence, and hopefully described in simple, like English language. I don't know, sometimes you get these very convoluted, people are trying to sound like they're writing in old English or something. I don't know, that doesn't, it's hard to understand. Simple, describe how the system is supposed to work. So a little quiz, just to test your knowledge of fuel systems. I was talking about high and low level alarms. At what levels should the high and low level alarms for a main fuel tank and a day tank for a typical generator system, where should they be set at as a percentage of the fill? Chirp, chirp, chirp. 10 and 90, is that what I heard? Nobody else has guesses? You cowards. It's a trick question. It's wherever the engineer of record says that they're supposed to be set. I'm just a commissioning person. You're not determining what that is. It's wherever. It's a good reminder, because I get asked questions all the time. I'm sure you guys do too. how do you want this set up? It's not how I want it set up. I mean, I'll tell you if you want, but it's not how I want it set up. It's what the construction documents say. It's what the engineer has set up. If there's no sequence of operations, then we need to get them involved and talk. So that's my little reminder for that. This is a real question, though. So it's a little counterintuitive. There's my diagram again. I spent a lot of time on that, so I like to show it. So we got supply pumps that are feeding to the generator and return pumps that are feeding back from the generator to the main tank. Which do you think would be bigger? Shout it out if you know the answer. It's okay. It's generally the return pumps, which is kind of counterintuitive because you think, well, the supply would be more important, but ultimately when we're talking about returning fuel from a day tank to a main tank, we're trying to prevent a geyser or a flood of fuel, so you want the return pumps to basically outpace the supply pumps in case the supply pumps get, in a worst case scenario, they get locked open so that they just keep running and you can't stop them. You want the return pumps to be able to outpace that return, typically. We also would have accepted however the engineer of record wants them set up. So I'm going to talk a little bit about fuel calculations. And you say, Mark, we don't get into calculations. We're just commissioning people. It's whatever you just said, whatever the engineer says is right. Well, that's true. But I also think it's important to have a good understanding of what the codes are and what the codes say. And I'm not going to go into a ton of detail about this, other than to say that there's a couple different codes that govern how much fuel might be required to be stored on site based on the type of facility it is and the critical nature of it. And to me, the biggest thing, the most important thing is that, I think I cover this later actually, is that those calculations are somewhere on the drawings so that I feel good about the fact that there's been some engineering that went into it, that the owner can feel good about that. But more importantly, from a ongoing operations standpoint, a lot of times the only documentation that anybody can find later after the job is done is the as-built, using my air quotes there. So having those calculations on the drawings will help the future building operators at least understand what the sizing criteria was for the fuel system and how many hours of fuel they are supposed to have, and maybe how much they can add to it later, rather than try to guess or go through those calculations. The other thing I want to point out that y'all probably know, but some people don't, is that just because you have a 10,000 gallon tank does not mean you have 10,000 gallons of fuel capacity. That there's unusable fuel at the bottom, there's a fill space at the top, so generally 15% of whatever that rated capacity is what you have. So if the requirements show that you need, if they actually showed that you needed 10,000 gallons in a round number, you would multiply that by additional 15% and come up with a bigger size. So a lot of times you'd want to see the nominal size of the tank and then the net usable fuel, because that's the most important number that you want to see in those calculations. What's the net usable fuel from the main tank? We could take the next 20 minutes and go through these calculations, but it's afternoon and I get that lovely afternoon after lunch spot. Could be worse. I could be Charles. He has the session right after us. Raise your hand, Charles. So if you want to learn more about lighting systems, commissioning of lighting and lighting control systems, stick around because he's going to be right here in this room right after me. Bless his heart. I've been talking about big systems, big main tanks, but a lot of times we just see simpler systems with a belly tank, whether it's a smaller generator or a bigger generator, but we see belly tanks put in a lot, and you don't have day tanks, you don't have return pumps. That's all fine. I still want to see calculations. I'd still like to see a simple sequence of operations, probably like one sentence. But recognizing that not all fuel systems are alike, I just want to point that out. These were actually 1250 kW, I think, generators, paralleled. It was a bigger at the time. I think they were one of the biggest ones I've seen with belly tanks, but you can do it. These are the biggest tanks that I had ever seen. They're two 25,000, I can't remember, 20 or 25,000 gallon tanks that are actually inside of a central plant. like in a room, which should not be legal because how many gallons of fuel can you store indoors? Anybody know? 660 is under certain conditions, 660 gallons. I don't know how or why they got away with this, but you know, this would be on the bigger side of fuel systems, but they still basically work the same way. And just to show you different components, I'm constantly surprised at how small, just an electrical guy, how small the pumps are that are going to pump from. This is the same job with the two 20,000 gallon tanks. Those are the supply pumps, duplex supply sets. The controller, little bitty 3rd horsepower pumps, you know, doing their job, and hand pumps there on the top. We're going to talk about that a little bit. It's a different system, but you know, day tanks in close proximity to the generator. This one happens to have fuel polishers, fuel cleaners right there associated with the day tanks, as opposed to a central system. Talk about that in a sec, but just showing you some of the components. That's basically the design phase, the things we're looking for. Or I'm looking forward to go through, set us up for success. So moving into construction phase. See, I gave away my better slide. I am also very surprised all the time that you review the drawings and you think you know the systems and you show up on site and you're like, well, where did that big gray box come from that has supply pumps in it? That's what the drawing said. I didn't see that in the submittals. Maybe you don't get to review the submittals, but you need to review the submittals because I see a lot of differences between what's on the drawings and what shows up on site. And I'm still not sure how that happens, how those things get approved in submittals. But for instance, this is a modest-sized supply tank that the details showed that the supply pumps were integral in the tank itself. You show up and there's if you'd open that box, that's got a duplex pump set in there. So making sure you understand it, looking at the submittals and verifying what changes, trying to catch what changes have been made and make the adjustments to your commissioning plan, and then looking for all those things that if we didn't get to do, especially if we didn't get to do a design review, all those things I said I want to look for in the design, I'm going to look for in the submittals. If we're brought on during construction, but supply pump sizes, return pump sizes, is there redundancy, where are they located, where are they supposed to be located, and still never too late to make comments from a serviceability, operations, ongoing maintenance standpoint. This is my favorite part of my presentations, where I just show pictures of stuff that you just can't believe they actually installed. Actually, I had to cut it down from what I normally show, but I always start with this picture, even though it has nothing to do with emergency power systems or fuel, because this is one of my first, what the heck did they do there, slides and pictures. And this is a library in Jacksonville, and if you go to the library today, that exit sign is still not over the door, which bothers me. So this is why we hire commissioning people. I did some work for my firm did some work for the state to help out as the AHJ for a lot of nursing home generator installations. So we did reviews and then would go out and do the inspections as the AHJ. And a lot of them were smaller generators with natural gas systems, which is fine. Went out and looked at this, and you'd think it was fine, but I was very confused because the drawings, which I had looked at, originally and then the day before I went, showed a diesel fuel generator and a diesel fuel system. So this is not diesel, this is a natural gas system. So that's just one of those changes that I don't even know how that happens, but I think it was bad details is what it was. Anyway, hand pumps on the day tank are required by code in most jurisdictions, especially for hospitals. I do a lot of hospital work, but in this project and a lot of projects, sometimes they don't get specified. In this one in particular, the engineer did not show or specify a hand pump associated with a day tank. So I made a comment, during a construction observation that I think you're going to need this. I think the AHJ is going to require this, so you might want to figure it out. Engineer of record was completely silent. He just didn't do anything. So the contractor, the plumbing contractor, bless his heart, he tried without Actually, he asked me to draw a schematic, and I said no. But bless his heart, he tried to, figure out how to put the hand pump in, how to pipe it in. And it took more tries than I'm showing pictures here before he got it right, which is the final picture with bypasses and valves and all that. But that shouldn't have to be the case, right? That should be specified and designed by the engineer. The contractor shouldn't have to be figuring it out in the field, and I shouldn't have to be, holding his hand while they're doing it. That same generator or our fuel tank room that shouldn't be allowed to have fuel tanks that big also has all kinds of other lines running through it, which is not supposed to happen either. So I'm not sure who inspected that building. This is a little more common. Generator rooms are tight a lot of times, and in this case, the day tank it's hard to tell in the pictures, but the day tank is, it's like exactly like 3 feet away from the back of the generator. And so the contractor thought they'd help out by introducing trip hazards and rip the pockets on your pants hazards as you walk by. The piping comes up here in the ground, and so we worked with the owner and the contractor to say maybe you should relocate some of that stuff so that it's not like in the way and we don't kill each other, kill somebody, a maintenance guy who's trying to just do his job, and they move this controller to the side here. Little things like that I don't know why people don't think of. Okay, well, there's supposed to be a picture here that shows, heck, man, that shows, it's actually the same installation, but shows on the back side of this day tank, between the day tank and the wall here is where they installed the hand pump, where you had like this much space to get to it that you couldn't possibly get there and install it. So that's I don't know why they do these things. This is a remote fill station for a generator that, this is where the tank comes and, they take the hoses out and they open that blue door and connect in the fuel lines, the hoses, to then go and feed the system. Happens to be inside of a parking deck, and as you might imagine, this is the outside wall of the parking deck that has this mesh screen thing. This is supposed to be flush with the outside wall, and that didn't get installed that way. For whatever reason, the pipes come up in the wrong place, and so I said, well, they still have to have access to it, so they just cut a hole right in the wall of that mesh screen. The architect was not very happy about, so they really didn't resolve it the way I suggested that they should. They basically just put another lockable door on the front of this, and so you still have to reach in like through this 2 feet of space to get to the fuel, the door to the fuel station. So it's I don't know, these things happen. This is another one where this is another tight generator room where the day tank here that is shown on the drawings, and I don't think we ever did get the submittals, but the design intent was that the return pumps were integral with the day tank. They usually come mounted on the top of the day tank. Well, apparently when the return pumps showed up, it wasn't, and the day tank showed up, it wasn't integral. It was a separate pump set, the remnants of which are here, that the contractor field modified, but didn't have room to set it in the generator room, so they mounted it high up here on the wall, where you can't get at it, you can't see it, you have to get a ladder. I had to get a ladder and to find a ladder, and get up there and just to take pictures of it. So does that seem very, very maintainable and accessible for the operations staff? No, not to me it didn't. So there's nothing they could really do about it, but at that point in the job, so we made comments and oh well. But those are the types of things that we'd really like to see caught and addressed during, if not during the design phase, earlier in the construction phase, although it happens. Remote enunciators. One of the things we're always looking for, and I'll talk about here more in a second, is that the low fuel alarm in the main tank has to enunciate in the generator's remote enunciator panel. So I go out and during construction I say, okay, they've got the standard NFPA 110 panel here. And I come back out for the functional testing, and the one that says low fuel has been taped over, says spare. So I was not confident that it was going to work when we tested it, and of course I was right. I'll talk more about that here in a minute. That's the backup in case people say, where does it say that that's required? Well, it says it in NFPA 110, lists here what's required under RA, what alarms are required to be part of the remote annunciator panel. The generator's remote annunciator panel and low fuel in the main tank is certainly one of them. So I'm always looking for that as well, making sure, because that gets overlooked a lot. That's another summary of kind of what I'm looking for when I'm going out during construction sites. Because remember, I'm an electrical engineer. I recognize that a pipe is a pipe. If it's that black irony looking stuff, it's probably fuel, maybe fire protection, but generally it's probably fuel. If it's these are the jokes, folks. It's it's a little funny. So my kind of the baseline that I go by is if I can figure it out. If I'm in the field and I can figure out how the fuel system, without looking at the drawings, how the fuel system is supposed to work with the pipe labels and pipe and valve tags, and figure out, then it's probably pretty intuitive and can feel comfortable that the new operations and maintenance guy who was just hired and can't find any as-built can probably address it, figure it out too. But if I can't figure it out and I have access to the drawings and I'm familiar with the job, then what are the chances that during an emergency that the operations staff is going to be able to know which fuel is spilling out all over the generator room, and they're trying to figure out what to shut off and what not to. The chances are they're probably going to have some trouble too, because you always got to remember that we might test when everything's nice and calm and have all the time in the world, but that's not when the problems happen. When there's a problem, then there's chaos involved. So I like to test to the chaos. So if I can figure it out, then you're good. If I can't figure it out, then we might have to talk about it a little bit more. These are some pictures I'm going to talk about for a job that we just recently completed, sort of completed. There's still outstanding issues for a high-rise office building in North Florida. Big main tank. In a room there, you can see the piping and labels are there. Duplex pump sets, which is actually what we were expecting to see. So that was nice. These are supply pumps. So I open them up and check make sure the motors work and all that. And I'll talk a little bit more about that here in a second. But that's what I was expecting to see: 2 duplex pump sets, fuel polisher, fuel cleaning system, fuel polisher system. So basically cleans the fuel as it goes from the supply tank out to the generator, so that we've got clean fuel. Fuel quality is an important issue. What we weren't expecting, that nobody specified, and I didn't see in the submittals, was a separate fuel cleaning system that basically, I said that the fuel just can't sit there stagnant in a tank and you expect it to work. So somehow they got this nice system where it pumps the fuel. Basically just pumps it out of the main tank through the fuel cleaner's fuel polisher that's in this cabinet, and then pumps it back to the tank. So it does that on a regular schedule, which, if you could see that, there's like a little calendar schedule, programmable schedule that, I don't know. They asked me, how do I want it set up? I don't want it set up. Mr. Owner, how would you like to set it up? So we talked to operations staff and figured out how often they wanted to, at what schedule they wanted to get this, have the system run, because like I said, it wasn't specified, so it wasn't even a thing that we were looking for in sequences of operation. Surprise. This is the day tank for that generator. The thing that's interesting about this project is the fuel tank was down at the first level of this parking garage, and the generator is up about 8 stories at the top of the parking garage. So that's why we've got some extra redundancy they have some extra redundancy on the fuel tank, or I'm sorry, on the supply pumps. But then here's your day tank that's in the generator enclosure with return pumps that then, if the day tank gets too high, we'll return fuel back down to the main tank. There's the hand pumps there, and when they went to test them before we showed up, bless their hearts, they actually went to test the system. They broke the hand pump, which means that it was a little hard to pull fuel, and then they replaced it, and we tested it, and it ended up working. But I'm looking for these labels. Again, if I can figure out, I'm a big fan of labeling and directional arrows and all that. So if I can figure it out, then somebody else can figure it out. So we've done all this, we've gone through all the construction phase, made all the comments. Are we ready for acceptance testing yet? Always like to look at, again, what are the requirements from NFPA 110, because NFPA 110 for emergency power systems, that's our guide. That's what we use as the basis for all of our functional testing. So go back and look back what's required by NFPA 110 and other codes for that matter for the fuel system. And I'm not going to go through all that. It's just so that it's included in your slides so that you've got access to it. But it's things we've talked about so far. I also like to look at, this is the after acceptance testing, this is the maintenance and operations schedule of what the operators are supposed to be testing on a weekly, monthly, semi-annual basis. So we're also thinking about those things. Is that going to be testable? Are we setting them up for continued operation, continued testing? And of course, the commissioning plan. I'm a big fan, imagine that, of having the commissioning plan be an indication of how you're going to actually do the functional testing. Apparently that's not always how it works, but all those surprises that I've talked about that we see on jobs a lot mean that I'm updating the test on a semi-regular basis as we get, from the design to the submittals to, okay, we showed up and it's still not configured the same way, so I'm adapting and tweaking the plan, in this case, for the main tanks, for the supply pumps, for the day tank, for the return pumps, as we go. So because I'm going to actually use this, and this isn't preaching to the choir here, but this isn't new information to y'all, where we try to get this information, get the test procedures into the contractor's hands so they know. We use the analogy that it's a test, but we're giving you the test and the answers to the test. Please study ahead of time. Use this information to help us all out. It's not like, surprise, we're going to test fuel today. No, it shouldn't be a surprise, because the other half of what I do, besides looking for single points of failure when we're looking at emergency power systems, is trying to wrangle all of these cats. That's the hard thing about emergency power systems, is you have multiple vendors and contractors that none of whom want to work together, it seems like, and they all say, usually you're testing with the electrician a lot, and then I say something about the day tank. He's like, "That's not mine. I didn't do the day tank." Oh, okay. Where's the plumber? We got to get the plumbing contractor up here. Generator's one vendor, and the transfer switches is another vendor, and getting all those people to get their signals to go from here to there. It's just, it's a miracle that any building gets built. Frankly, I don't know how buildings get built. So I'm ready to test the pumps, and this is generally, or test the fuel system. This is generally how I'm doing it when we get to functional testing of the fuel system. I'm going to test the supply pumps. I'm going to try to overfill the day tank by, this is where the videos would have been nice. I'm going to, in this case, push the supply pump, run supply pump button, and watch it, move fuel and fill the day tank until it gets to its high level. Hopefully the sequence of operations has said at what level that is, 90%, whatever the engineer has set it at, for the float switch to kick on and turn on, and shut off the supply pumps and kick on the return pumps, make sure all that works, and then I'll reverse it. We'll run the return pump until the day tank gets to its low fuel level, and watch the opposite happen. Watch the return pumps kick off and the supply pumps kick on, and make sure that all that's happening automatically. Pretty simple, right? How hard could that be? Well, first of all, in this project, the supply pumps that I was showing you were the nice duplex controllers. We were testing those they were doing their startup, and I was watching, and I touched things that I'm not supposed to, and that can get us in trouble, because they were just running. We're just trying to make sure the pumps run, and they were, I forget exactly why, but I went over and I turned on the pump into, it was both pumps. They tested one pump, and then they tested the other pump, and I said, well, will they both run, or are they alternating, or are they both going to run together? And I went and I switched the things into hand, and both pumps started, and everybody looked at me like I had lost my mind, and they ran over and they shut them off. said, you're going to blow up the system. I'm like, well, how am I going to blow up the system? Well, because the solenoid valve in the supply line up 8 stories in the generator enclosure is closed. I said, well, it's supposed to. The sequence says that it's supposed to open whenever the supply pumps run. That's what happens. You run the supply pumps, they start, but they also open the normally closed solenoid valve in the line so that the fuel can actually flow. Well, that line, that valve was not, there's a diagram, it was not opening. And so we got into this big discussion as to why that was the case. Because it should be the case. And they said the valve only opened when you pushed the run pump on the day tank that I was showing you in the slide earlier. And I said, that's not what's supposed to happen. It's supposed to open anytime the supply pumps run, so somebody doesn't do what I just did, 8 stories down, and run these pumps in hand. So that got into one of those discussions of, well, that's not my wire that runs from here to there to we got to run it down 8 stories. Like, I don't care. So it was a big discussion. This is why we do commissioning. And that's all kind of outlined there if you're not following along. But typically, supply pumps run, valves have to open to allow the fuel to flow into the tank. So they need to fail in a safe condition. And this would show, if these videos were working nicely, would show me doing that, pushing the supply pump on supply pump run on the day tank. And we weren't moving fuel at first because we were just standing there and standing there and standing there and nothing's happening. And then we realized that there was another valve that was closed in the system, and then finally, got it to run and watched the return pumps kick on automatically when it got to its high level. And then when we're done with that, we also do that with the hand pumps to see if we can actually move fuel. You just got to crank on the hand pump for, depends on how long it is, how far away it is, but to make sure that we're actually able to move fuel from the main tank to the day tank. That's your backup safety provision in case the supply pumps fail for whatever reason. Shoot. Then we also test as part of the whole emergency power testing, where we test the remote annunciators, like I said. And the reason, again, that I'm looking for, is there an alarm for low level in the main tank? The reason sometimes they decide not to wire that is because there may be a main fuel system monitoring system annunciator, very nice panel. I don't know why fuel guys get the nice, pretty looking things and we get these. So we're sitting right next to these panels, and it says when the system is low. Like, well, does it alarm? Well, no, but you can read what the fuel is. And, well, even if it did alarm, it doesn't matter. The code says that it has to be part of the generator's remote annunciator panel. So we're testing all that to make sure that works. And again, that's the third piece of our triad. Yeah.
If you had a skid tank or your main tank, how would you test that low level?
A skid tank just for with or without a day tank? Well, it really wouldn't matter because there's still going to be a float in there. Sometimes what they do is I get them to basically manually lift the stem on the sensor just to simulate, rather than moving the fuel, move the sensor. And it's harder to kind of calibrate that way, but I want to at least see that the alarm is going to do a thing. Yeah, that's true. You can do that too. But I'm usually not there when they fill the tanks and they say that, well, we did it. We tested it. Okay. You say so. I take your word for it. Say, I don't trust. It's not that I don't trust you. I don't trust anyone. But yes, doing it when you fill the tank is a really good one. I'm sorry? Yeah, it's not. Yeah, low level is kind of a misnomer because it's if your fuel system is if it's a class 48 system and you have to have 48 hours of runtime and you size 133% of that, and maybe the tank's a little bigger, it still has to alarm low level at 48 hours, which is you still got a lot of fuel left in the tank. So yeah, it's important that they understand that as well, what low level means. Anyway, so once we do all those, generators tested, the transfer switches are tested, the fuel systems are tested, and I got checklists completed and everybody signed off, then we'll go through and do the full EPSS functional testing of the whole emergency power system, which seems a little redundant sometimes, but that's when we do, whether it's part of integrated systems testing or it's just, a generator only test where we're going to turn off power to either the whole building or certain branches and watch everything happen automatically, right? Watch the generator start and transfer switches transfer, and I might redo some of that testing while the generator is running, run the supply pump and try to, get the high level alarms, run the return pumps, get the low level alarms while the generator is running. Again, we're trying to test it in all modes of operation, not just when everything's nice and calm. And so that's basically the whole thing. So it's all about teamwork and all about getting the people to work together. And like I said, one of the biggest challenges is after getting all the documentation done is trying to juggle all of the people who are saying, that's not mine, I didn't touch that, I only take the wire this far. Get the owner or the general contractor to bring their hammer down. But high performance buildings are about teamwork. Here's my contact information. If you have any questions after today, you can always reach me and we can talk about questions now. Yes, sir.
Mark, do you ever get into testing or commissioning the filtration or polishing or larger sand filters type stuff? What do you do?
The question was, do I ever get into testing of the fuel polishing system? And the answer is generally no. I want to make sure that fuel is running through it, and other than a visual inspection and you're maybe talking to the vendor and the contractor, I don't really get into that much level of detail unless the client really wants us to. Maybe we should, but no, we generally don't.
Had any issues with the DEF additive system?
Have we had any issues with the DEF additive systems? No, not that I can recall, but again, sometimes we're gone by the time that, any kind of lingering issues with, fuel quality or fuel additives would get into the system. But no, not that I'm not a fuel expert per se, but no. What kind of problems have you experienced or heard about?
I wasn't involved with it, but it didn't work. I can tell you. Had to get the manufacturer back out there to work on it.
Okay.
I don't know if it was because I guess all diesel systems have to have this now.
Yeah, that's my understanding.
Right, and these were natural gas boosted diesel machines,
Oh, interesting.
so they were high cost.
Other questions? Troy.
And that broke too.
And did you run a positive displacement pump and a valve flow like a solar valve, lift or release valve? It just take back to the tank or just flow over it?
There has to be, the question was if you have a solenoid valve that's closed and your pumps, we're trying to pump against it and you lift the stem, what happens to the fuel? Does it still go through or what happens? And the code does say that you either have to have a liftable stem or you have to have a bypass. And I see more and more people just putting in a pipe bypass, close a valve, open a valve, and it just bypasses around the valve. So it's still going to flow through towards where it's trying to go. It's still trying to go to the day tank typically. So it's still going to get on that path. But if nobody's up there, then it was one of the challenges that we had on that project is that, and it happens all the time, is that where the generator is in that case is very remote from where any operations people normally are. And I was talking about the code requires the low-level alarm for the main tank. Code doesn't actually require any alarms or indication for the day tank. The day tank could be literally have a hole in it and leaking fuel all over the generator enclosure, and unless somebody was up at the top level of the parking garage, nobody would know about it. And that's not good. So we actually talked about that as part of the, from an operations and maintenance standpoint, and the building engineer said, yeah, that's not good, we should do something about that. So they actually added an alarm or going to add an alarm to the system to basically just a low-level alarm for the day tank to enunciate as well. But anyway, other questions? Yes, sir. Well, let's see how far back we can go. So the question was, one of the slides I have back here was talking about there's limited space in the generator room, and where they were installing things on the day tank. And this one is the one you were talking about? Oh, that's not the one I thought you meant. Well, this one is a different set of issues in my mind, that the pumps are not accessible. They're not readily accessible from from an operations and maintenance standpoint. Right. The drawings showed that the day tank, and the specification showed that the day tank had integral return pumps, like mounted on top of the day tank, like similar to the other one I was showing. Well, apparently their option is to mount it on top of the wall there. Acceptable is, we actually talked about whether this was a code violation or why they couldn't be there, and it's hard to point at a specific code that says, oh, you can't put the pumps up there, but from an operations and maintenance standpoint, they're hard. So that's what we look for, right? We're looking out for the facility guy who has to operate, has to maintain, if these pumps don't work, and you got to do something about it, it's not readily accessible. So at that point in the project, by the time we got on site and realized that, it was too late. It was already installed. It's not like they could make the room bigger. The contractor took it upon themselves to put them up there. So I asked that same question. Is they just decided to put it there, or was there an RFI or something? And
Who approved it? That has to be discussed before they do it.
I couldn't agree more. It should be subcontractors should be going to, hey, we have a problem. This pump set showed up, and I don't know where. It's an RFI. It's part of a meeting, with the GC and the design engineers. It should be. I couldn't agree more. As best as I can tell from talking to people on site, and the GC, general contractor, is they kind of just did it, and it was like they didn't have much choice, and the engineer kind of, after the fact, not much they could do about it. Yeah, no, they didn't change it. There was no way to change it. It's not like, oh, there's this nice big space here on the generator room floor that you could put the pump set, because that would have been nice. But no, that's the difference between what I would have expected or hoped would have happened is that gets caught in submittals, right? Is that somebody.
That was the designer or the engineer mistake, and the designer, they didn't actually.
I don't know whose mistake it was, or whose fault it was, or how it got ordered differently than it was specified. It wasn't me, so I was happy about that. I don't have to blame somebody. But I would have liked for somebody during the submittal review process. It's easy to have 20/20 hindsight or whatever. If I was an engineer, I would have caught that. But ideally, the design engineer's reviewing the submittals and says, hey, this is a separate package pump set. That's not what we specified. That might be okay, but is it going to fit in the room? And go from there. Or that's coming through. I get on a whole thing about how submittals go, but the plumbing contractor obviously submitted, through their vendor, submitted that. The GC stamped it with their approved stamp, which, wouldn't it be nice if a GC actually, are there any general contractors in the room? If they actually looked at stuff and said, hey, this is different, it's part of the process, which when people say, why do I have to do commissioning? Don't I already pay for that? And that's when I break out some of the slides and say, that's just not the way the industry, right, wrong, or indifferent, is working. So having somebody that's actually looking out for these things is kind of important. No, it's not my fault. No, we got hired after construction had started, and we reviewed the drawings, and I asked for submittals. I don't know that we ever got them. It was a very quick turnaround.
Would mounting them on top of the tank have been an option?
I asked that too. I mean, can't we,
Put a plate
take these pumps and like literally mount them on the top of the day tank like, they would have if it was a package system? And one, they weren't thrilled about redoing and repiping the entire system just because I thought it was a good idea. But also there's potentially warranties and UL listings of, you took a packaged pump set and then took it all apart and put the pumps on, on another thing that wasn't supposed to have it. So all they did was take the packaged pump set, instead of mounting it on the ground, mounted it, 10 feet in the air. Oh, well, we're just about out of time. Anybody, any last questions? No? Okay. Well, I'll be around if anybody has any questions. Thank you for your attention.